Okay, so scalability, right? The ability to either, what do you call, increase the setup. Okay, I mean, increase the range of your operation, right? So if at all there is an extra feature that you want to add, right? We saw the different examples, right? In your speedometer, for example, you want to add in more controls, so you can scale it. There is easy, it's easier to do changes, right? So because you have modularity, and that in turn reflects in your scalability, right? You can scale it, scale your system, like add more features, right? More PLCs or like that. So scalability is another benefit. As for relays, we saw that you were having that the problem of connection, right? All those wires we saw in the video has to be connected, right? So there was physical connection, and that was a problem with, that will come as a problem when you're trying to scale the system up. Okay, scale it up. Scale it down also, same thing, that you'll have to know which connection is where. So scalability is another benefit. Okay, existing system setups can be expanded conveniently, as opposed to microcontrollers which come with fixed designs. So in your microcontroller as well, so there's not much that you can do. Okay, because there are fixed design, you have all those uh, already fed, right, embedded. So changes are very difficult to make, and that will affect your scalability. Okay, safety. So diagnostic features are installed in all PLC devices, such that before that before the system even starts, it detects errors that the operator or programmer may have overlooked in his PLC commissioning. So you see, even before the system has started, it will diagnose the the PLC system is so programmed that it will diagnose as to if there are any errors. Okay, not after starting but before starting. Okay, to detect errors. For example, the operator or programmer may have put in a wrong program. Okay, that may in turn, that will affect your system. Okay, the system's performance. So diagnostic features are installed in the PLC devices, right? That is another reason. Okay, and what you call that uh, thing is called PLC commissioning, when you're trying to set up the system. Okay, robustness. So PLC, we have discussed the word robust, right? Robust is, a system is called robust it when it does not change with external changes. Okay, if there are any external changes, okay, maybe, for example, if you take the example of a phone I gave, that because of the temperature change, either the temperature is too high or too low, that should not affect the phone's performance. Okay, to certain limit, right? So more is the limit, more is the robustness, right? If it can operate well in between plus or minus 50 degrees, okay, temperature, then you can say it robust. If it is more, then you can say that's more robust, right? Because the performance of the phone is not affected. Similarly, PLCs are immune to noise, power fluctuations, etc. So noise in the sense your electrical noise. Okay, like in the factory, there will be different signal connections, right? That radio waves, etc. All of that will affect the PLC's performance. So that's why you have a hard cased, right, setup in PLCs. So that makes it immune to noise, power fluctuations as well. Okay, if at all there are any power fluctuations. So microcontrollers comes unshielded, right? As I told you, they they come unshielded. PLCs are hard, having those hard outer covering. So microcontrollers do not have have that. So they cannot handle the extreme conditions in the work areas of the industry. besides the inability to handle high temperatures for a long period of time, right? If at all it is functioning for a, and industries do work for a long period of time, so extended period of time. So if that ability is not there to handle at high temperature, then that makes it very difficult to use in the industrial domain, right? So that is another reason why you are calling it robust, because it can handle high temperatures for a long period of time, okay, besides other benefits. So doubts in this slide, questions? Yes. Okay, so other reason is maintenance. So you see, very in low maintenance as regards to the PLCs, because they are robust, right? That robustness will in turn affect the maintenance part. Also, because the program is easily readable and standardized, maintenance electricians assigned can check the easier connections to troubleshoot quickly. Okay, because of easy readability of the program, right? And standardization also. Like for example, you in the case of microcontrollers, you may have a different kind of what do you call, connections can be, because different technicians will do the connections differently, so there's no standardization, right? But in here for PLCs, because there is transparency, right? You can easily see which connections are pointing out where, right? Even in the those ladder logic diagrams will be available, so you can see what part is connected to what, and connections, both in at the time of making connections and also troubleshooting, right? If at all there is uh, there are problems, okay, while the PLC was operating, right, in the industrial context. So even that troubleshooting can be done, okay, as to identify what problem is causing the delay. Okay, standardization. So companies prefer standardization over customization, isn't it? As I told you, instead of having a customized version, you can, if it is a standardized version, then the reasons why we are saying standardization is preferred is because it can be done easily, right? It's easier to identify, uh, because people come and go, right? The personnel will change, the technicians will change. If there is standardization, then they will identify easily. If there is customization, then only those who had installed it will better know it, right? Although they can, the new employees can identify that, but it will take time, right? So that is why companies prefer standardization over customization. And with the help of this standard, there's a standard in the industry called IEC 61131 standard. All companies worldwide already have a guideline to follow. Okay, in PLC systems, this eliminates confusion in troubleshooting or in programming. Okay, especially when there are different people involved in the same task. So different people involved in the same task, right? As I told you, those technicians and the automation engineers as well. So when you have a standard in place, there are standard guidelines, isn't it, as to what to do and how to make connections, how to uh, install that. Okay, so all of that will help us, right, in avoiding delays and increasing the productivity. So less upfront cost. Although you see microcontrollers are cheaper, okay, that is one fact, that microcontrollers are cheaper, but their qualities are not just the ones that companies are looking for in the industrial side. They are cheaper, but the qualities that are offered by the microcontrollers, they are not up to the standard, up to the expectations of the industry. Okay, so it's really quantity over quality with high productivity for them. So the industry looks for quantity over quality, okay, in a sense, with high productivity. In the long run, the PLC would produce less downtime than the microcontroller based ones, thus generating more assets for the company with a lower maintenance cost. So you see, PLCs are initially expensive, but still the advantages that are offered by the PLCs are far greater than microcontrollers, which are cheaper. Okay, is that clear? What we're trying to say? Less upfront cost, meaning the cost that will be incurred later. Okay, the cost that is to come later. Okay, after your installation of the PLC or the microcontroller. Okay, once it starts operating, that cost, okay, your maintenance cost, okay, also your, because there is less downtime, so that unproductivity or loss of productive time will have a cost, right? When the machine is not performing, okay, because the microcontroller is not performing, then you have what you call idle time, right? Idle time of the machine. So the production stops, so that in turn affects your production rate. No products being produced, therefore that will come as a loss. So lower maintenance cost, less downtime, right? All these are advantages that you get, and therefore that justifies the initial higher investment of the PLCs. Okay, was that clear? What we mean by less upfront costs? It's not very apparent, right? Not very clear as to how that uh, initial higher investment will give us. How can we say that there are less upfront costs? It's not less initial cost, it's less upfront cost. Okay, clear? Or questions regarding that? Okay, so that was that. Overall, PLCs are used widely in the industrial side of automation and control systems. Although microcontrollers may be used in highly specialized systems, they are just not suited for the battles that the PLCs face in the industry. PLCs have less complexity, cost efficient, and robust. That's generally the reason why they are preferred for industrial control systems. So you see, microcontrollers are there. You might ask, why are we then using microcontrollers? They are there, but the usage is not in the industry. Okay, highly specialized systems. So in the industry, you will use it because we discussed several examples, right? So in chemical plants, you have these PLCs being installed. So to control the different what do you call, processing equipments, right? So in those, you will use PLCs because of, we discussed, right, all of these reasons. And you see, all of these reasons are all of these benefits are required, or you can say all of these features are required in the industry, right? Because you will have maintenance issues, right? All of these are real issues in industry, and PLCs offer what do you call, PLCs are one way to avoid those issues, right? In terms of microcontrollers, they are the only way, you can say, when we compare it with a microcontroller. So microcontrollers are used in highly specialized systems, but not for the industrial controls, okay, that the PLCs face in the industry. They have less complexity. These are the three reasons generally. Okay, the three most common reasons why PLCs are used: because they are less complex, okay, easy to understand, easy to program, cost efficient also in terms of the later cost, okay, robust also, right? We saw why. So those are generally the reasons why they preferred. All of these are the reasons, but generally those are the main reasons, right? So there are even, what do you call, I told you, right, different softwares have come up even for just for programming the PLC. Okay, so they are complex and they are used in combinations, each for a specific application, right? So doubts or questions? It's already 2 p.m. Huh? So if you don't have any doubts, then we can close the class. Okay. Okay, and about the quiz, I will inshallah conduct it tomorrow. Okay, hopefully tomorrow uh, afternoon you have the class, right? I'll post it in the group also. Okay, do inform your friends as well. Okay. Okay then. Thank you.